So this is L32, and if you're watching this, then we made it to the end. So this is the last one. I do recommend watching his video because he does explain it a little more, but let's just jump into it. So C4H10, I'm going to draw my 4 carbons. It's got no negative DEPTs, which means there should be no methylenes. So no carbon with 2 hydrogens. So this one's not too bad. I'll just go ahead and draw that. So I have my 4 carbons, and none of them have 2 hydrogens. I've got my methyls, but no methylenes. And then I have this chart here for you guys. Okay, so on my video, I messed up and I wasn't able to fix it until the end, but this molecule down here, I accidentally put 2 purple rings, but one of these should be a different color. So I just wanted to let you know, so throughout the video, if you use this, just keep an eye on that. One of these should be like green or whatever color you want to use to indicate they're not the same molecule. This is like the one he had, and it's just showing the basic different isomers with the signals. So let me show you how to do this. This one has 2 signals. So that means these pink ones are equivalent and come up as 1 signal. These blue ones come up as one single signal as well. So that's why there's only 2 signals. Compared to this one where the pink ones, those come up as 1 signal. This comes up as 1 signal. This one is 1 and this one is 1 to equal 4. So I think I'll be referring to this during this lesson, but it did help me go through it the first time around. So let's submit that. Okay, I don't know if this is the one he had on there. So I'm going to draw my 7 carbons. 1, 2, 3, 4, 5, 6, 7. And then I see it has 1 negative DEPT, which means it's going to have 1 methylene. And with this one, I found so usually when it's a lower number like this, there's some branching or symmetry. Oops. So with this one, to only have 1 negative DEPT, which is 1 methylene, I'm going to want it to be mirrored because I have an odd number of carbons. So let's see if I can get that to mirror. Okay, I'm going to take out this one. So I see I have a center carbon. Okay, so at the end, we have 7 carbons. We have this one that's equivalent to this one, so that's 1 carbon signal. This is equivalent to this one over here, it's 2, 3, 4. These 2 are equivalent to each other. It's on the top and on the bottom. So I have a total of 4 carbon signals. And my methylene, since it's mirrored, I have 1 negative methylene, but these are the same. So even though I have 2 shown, it only comes up as 1. Okay, so if it's mirrored, like if it's symmetric like this, then you can have 2, because it basically just counts as 1, like we did with the counting. 1 signal, 2 signals, 3 signals, 4 signals. So let's see if that's right. I would draw, but I don't know if it'll take off this. I'll try in the next one. So 5, I'll draw my 5 carbons. And then it has 4 signals, so I'm actually going to go over here, and I see right away 4 signals, 1, 2, 3, 4, 5 carbons. So I'm going to go ahead and use this one. I'm going to clear it because, yeah, okay. 4, 5. This one's pretty easy, just because we have that chart over there. So I didn't have to worry about the methylenes here because it didn't say anything about the DEPT. Okay, 6 carbons with 2 signals, no DEPTs. So I'll go over here. 2 signals. Do I see anything over here? So this is my 6 carbons with 2 signals. 3, 4, 5, and 6. These 4 outside methyls are equivalent. These 2 inside carbons are equivalent. So that's why we only have 2 signals. Okay, I have 5 carbons with 3 signals. I'm going to go to my other chart. I see 3 signals over here, and 1, 2, 3, 4, 5 carbons. So a pentane chain. 1, 2, 3, 4, 5. Add my hydrogens, and I'm ready to go. The outside ones are the same. These 2 inside are the same, and this one is by itself, for a total of 3 signals. Okay, so I have C4 with 1 negative DEPT. So I'm just going to draw it like this. I know that it's not. So I have 1 negative DEPT, which means I have a methylene, and it's not possible with this. So the only other one I can draw is this one. And it makes sense because these are the same signal. So we've got these 2 the same. Let me see if I can draw. Nice. Oops. So these 2 are the same for this all intents and purposes, and these 2 are the same. So at the end, that means that it's only going to come up as 1 methylene in this because they're basically equivalent. So this is the correct drawing. And hopefully we'll get the C7 one with 3 negative DEPTs. Oh, here we go. Okay, so for this one, I'm also just going to draw. Let's see if I have it here. I don't think I do. 1, 2, 3, 4, 5, 6. No, I don't. That's 3 signals. Okay. So I don't see anything on here that lets me know that I have 7 carbons and 3 signals. Nope. Okay, so I'm actually going to draw this. I think this is the chain. Let's see. I don't have this on my notes, so we're going to do it together. 1, 2, So I believe it's chain 1, 2, 3, 4, 5, 6, 7. Oh, so it's 4 signals. Let's see if I had that. I thought it was 3. Nope, I don't, but I'm pretty sure it's a chain. So I'm gonna go ahead and find our ones that are equivalent. So I have those two, those two that are equivalent, and then lastly I have that center one. I need 3 negative, but as we know, these two are the same. These two are the same, and this one is on its own. So that means I have 1 methylene total for this pink one, for these both pink ones, 1 methylene total for these 2 blue ones, and 1 methylene total for this light blue one. So I have 3 negative because they're equivalent. So all I have to do is add my hydrogens. I had 4 carbon signals, so it should be good to go. Okay, so I have 5 carbons and 2 signals. So I'm gonna go to my chart. 1, 2, 3, 4, 5 carbons, 2 signals. So here it is. So some of them won't be that easy. You'll have to actually try to work it out like that previous one I did. But I found that a lot of them, like all of this really helped me. 5 carbons, 2 signals, 1, and then 2, because all these methyls are equivalent, and this is on its own. Okay, 7 carbons and 5 signals. I'm going to go to my chart. Bless me. Okay, 5 signals. I think that's what we had. Yes, and 7. 1, 2, 3, 4, 5, 6. I can add another carbon here and make it 7. Also, I don't know why this one's purple, but this should actually be a different color. So let me actually change it. I'll do a different pink. I'll change this one. So that's actually a different color to make 5 signals. My bad. Okay, so we're drawing this one at the end for 7 carbons. 1, 2, 3, 4, 5, 6, and 7. And let me make sure it's the right one. So I have these all 3 the same. So it's 1 signal, 2 signals, 3, 4, and 5. Add my hydrogens. And we're good to go. Okay, 7 carbons, 4 signals, no methylenes. So I'm gonna go over here. I have 4 signals. That's not gonna be it. This one has 2 methylenes. 1, 2, that has a methylene. Okay, so I'm going to have to figure this one out with 0. So let me see again. Okay. So I'm gonna start, since it's gonna be 0, I know a lot of it's gonna be branched. So I'll start with here. I've got 1 signal so far, 2, 3, and I need a 4th signal. 1, 2, 3, 4. I need 3 more carbons, so I can go ahead and add that to make it different than this one, which ultimately ends up giving me 1 signal for these 3, 2 signals, 3, and 4. Add my hydrogens. And the reason these methyls are different than these methyls is because these are attached to a carbon with no hydrogens. It's different than this one. So if I didn't have this methyl and it had hydrogen, these would essentially be the same, and the methyls would be the same. But since this carbon's different than this one, these 2 methyls are different than these 3 methyls. Okay. It takes so long and it stresses me out. Hey guys, Danielle here. I just wanted to put a face to the voice you guys have been hearing. And hopefully I'll see some of you guys online next semester. If not, maybe for my fall semester, I'll have some of you guys in my classes. If you do see me in the fall, make sure to say hi if I'm walking around campus. I don't bite. But good luck to everybody on your finals this week, and good luck with our coming semesters. Bye, guys.